Hey bio team. So one important type of protein is an enzyme. And an enzyme is just a type of protein that gets reactions started. We say they catalyze reactions. And like other types of proteins, enzymes are folded chains of amino acids, but specifically they're folded into a position where they can either break apart or synthesize a substrate. So we'll watch this enzyme, which is shaped in the right position to break apart this substrate. But we'll also watch it catch each piece of the substrate and synthesize them together. Now, from an energetic standpoint, what's happening when an enzyme catalyzes a reaction is that you have your substrate before the reaction, your reactants, and you're trying to react them into products. However, this is very difficult for certain substrates to do by themselves because in order to react, these substrates need to collide with each other at a high enough level of energy. They need to hit each other with enough force, and they need to hit each other at the right angle. So you can think of the substrate as kind of like a helpless toddler that's trying to get dressed to go outside in the winter. Theoretically, the toddler could figure out which arms go into which sleeves, but it's pretty unlikely that they're going to be able to manage the process by themselves without some sort of outside help or guidance. And so this is where an enzyme comes in. An enzyme plays the role of an adult helping a child get dressed. The enzyme latches onto the substrates and puts them in the exact location where they can very easily bond together or break apart. Now, just like other proteins, enzymes are made from a long chain of amino acids that have been folded into a very precise shape. And it's their shape, it's their form that allows them to function properly. Now, there's a couple of things that can cause this chain of amino acids to fold differently. For instance, if the pH level surrounding the enzyme becomes too low or too acidic, that is, there's too many hydrogen ions, or the pH level becomes too high, there's too many hydroxide ions, or the temperature becomes too low, or the temperature becomes too high, or if there's a mutation in the chain of amino acids that swaps out a polar amino acid for a nonpolar amino acid, or vice versa, it's possible for the enzyme to denature. That is, its form can literally change such that it can no longer attract its substrates. Now, this is normally a bad thing for enzymes to become denatured, for them to lose their function. But there are some instances in which chemists or biologists intentionally try to regulate enzymes. They try to inhibit enzymes. For example, some antibiotics will block enzymes that allow bacteria to grow. One type of this inhibition is called competitive inhibition, in which a substrate which is about to be reacted by the enzyme is blocked by a competitive inhibitor. It's a protein that basically takes up the active site on the enzyme and blocks it from breaking apart or putting together any substrate. Another type of inhibition involves non-competitive inhibition, in which an inhibitor attaches not to the active site of the enzyme, but to the back side of the enzyme, a allosteric site, a different site on the enzyme, and that causes the enzyme to kind of bulge out, to distend here, preventing it from matching with its substrate. And that's it. At this point, you guys have some practice problems. We'll see you next class.